Okay, so this will be a quick presentation related to an idea that I've been working on for some time. After the presentation, there will be as well a short demo. So let's get started. TH AI processor architecture PoC. So the event flow, um, let's first take a look here on the event flow and how things are actually happening uh, when we have the AI ML processor um, included, let's say. Smart connector, of course, an Avro smart connector, which is directly forwarding events to the TH ArcSight Avro topic. Then from the TH ArcSight Avro topic, data is getting routed and is getting forwarded towards the TH AI inbound. I have created this topic from ArcSight Management Center and also the actual route I have also created from ArcMC. So the TH AI inbound is going to forward all the data, all the events that have been essentially forwarded and received under the TH ArcSight Avro. So from there, what happens is that all this data is pulled, right, by our AI slash ML slash threat intel model, uh, which is based on the isolation forest anomaly detection. Um, the model has been trained on, in my environment, 20,000 events. And of course, since I'm dealing with a test alert connector, I couldn't really train it on more events. I mean, I could technically train it on 30,000, 40,000 or more, uh, but the actual noise reduction is going to go to 60, 70, 80%, right? Because the feed and the data which continuously is getting forwarded by the test alert smart connector is going to be the same, right? And with time, eventually the model is going to learn that this is just a noise and it's actually something normal, right? So that's why I have just decided to train it on less events. Okay, so basically the isolation forest model, yeah, is going to evaluate each and every event in real time against 18 features, which we're going to discuss a little bit later. And those 18 features have three possible outcomes, right, after evaluating the event. Either the event is going to get classified as a noise, or uncertain. The model is not really certain whether if the event should be put it under noise or under signal. And the last one is signal. In this particular case, this event has been, as you can see, classified as signal. Why signal? Because the AI ML, right, since it's also integrated with the threat intelligence component, and you can follow up here, okay, you can see that the event is going to be checked against some IOCs, some indicators of compromise. Those indicators of compromise are essentially stored inside here, inside Redis, and also they're essentially stored thanks to a cron job, right? Which is basically pulling indicators of compromise every 15 minutes from some well-known threat intelligence platforms. Okay. Inside Redis, currently I have stored somewhere around 40k, 40,000 IOCs, so plenty of data that is super useful as well later for the demonstration. Okay, so what happens is that in this particular case, for this event, an IOC is found. So there is a match, okay? For example, the attacker IP address, okay, is a well-known attacker IP address, and since there was an IOC associated with this IP address, this is getting detected, okay? So with step number 6, you can see what it says, IOC found. Now, Since an IOC is found, immediately the AI model, I mean, the original logic, which probably could have been a noise, right, is getting overwritten, okay, by default, and the event is getting automatically becoming a signal, okay, since this field, the device custom string 5, is getting this IOC detected, right, stamp, and then you have additionally the attacker IP address, the threat intelligence platform that has managed to retrieve and actually match this IOC, and then further description and classification. Okay, so then what happens after an IOC is found? Then we're prioritizing this event. We have enriched the event with some additional information, right? And then we're forwarding it back to the transformation hub. Now, after forwarding this event back to the transformation hub, is going to go here under the TH AI inbound topic, and then from the AI inbound is going to be forwarded to MF event Avro ESM filtered. Why is this necessary? Because we know that natively the transformation hub can use as a source enrichment topic, right? Either this one or the TH ArcSight Avro. Now, since we have already used the TH ArcSight Avro uh, to receive all the raw event data, let's call it this way, although it's not really raw event data, it's base normalized, right, categorized already data, but it has not really been enriched by the AI component. Yeah. The only possibility remains this particular topic here called MF event Avro ESM filtered. So as you can see, the enriched um, uh, router, let's call it this way, points to the MF event Avro enriched, from where we know that the Kafka scheduler is pulling data and is forwarding it further towards the Vertica, and then the object storage component, which can be MinIO or another appliance. Not only this, right, but also since this event, right, has been classified as a signal, okay, we want to actually send it for correlation purposes to this topic right here. Take a look. It's called TH. Actually, this 6 is wrong here. I should remove it. Sorry about that. But yeah, THAI Avro ESM topic. Okay, this topic which I have again created from ArcMC, and then I have just subscribed my ArcSight Enterprise Security Manager. So what ArcSight ESM is going to do? Immediately, analysts using, for example, on an active channel can detect and can see these type of prioritized events on a very early stage, on a very early level, let's say. And furthermore, of course, if rules are designed in a nice, proper manner, right, they are going to be able to further pick and correlate this event. Okay, so let's take a look at the AI ML component. The AI ML component essentially can be trained on live events. And in my environment, since I'm having only a test alert connector, like I already said, I have trained my model on 20K, on 20,000 events, but this can be, I don't know, 100,000, 1 million, and more. The only thing is that it's going to take some time. For example, just for instance, 20,000 EPS, it took approximately 10 minutes or something like that. So yeah, depends from the scale, and depends how quickly events are processed and they're passing through the TH AI inbound topic of transformation hub. Okay, so this AI ML component has 18 evaluation features, let's call it this way, and each and every event that basically passes through is getting evaluated against those. So every event is scored in milliseconds and is assigned a simple label, a simple tag. You can think of it like this: a signal, uncertain, or noise. The model can be retrained at any time on live data if it's necessary. It's very simple, by the way, 2 commands literally. And yeah, the more you expose it to live data, the more accurate it will become with time, because it starts understanding, in quotation marks, what is noise versus what is unusual when you deploy, of course, that training in a real environment, that trained model in a real environment. I mean, okay, the four core files of the ML stack. Uh, so yeah, there are four core files, and if you look at the bottom, you will also see the logic. Once an event comes from the transformation hub topic called THAI inbound, what is happening? The processor file extracts those 18 data points of interest and basically calls the ML model, which was previously trained by you. And like in my case, it was trained by me over 20K events to provide some useful classification for the events that are passing right through. Either they're going to be classified as a noise, uncertain, or signal. Um, okay, there is this third component, the SHAP explainer. This is how it's called. This is part of the user interface and has, when you scroll down, right, the user interface has one additional dashboard, which basically provides some additional context on why this event has been, for example, classified as a noise or as a signal. And yeah, this is handled by this SHAP explainer. By the way, if you're wondering how it's looking, this is how it looks. I have added just one additional slide. AI explainability. So you just pick an event of interest, okay, and then here you are gonna get additional context based on those 18 features that were evaluating, let's say, the event, why this event has been, for example, classified as a signal or as a noise or as uncertain. Okay. Now, what can be improved? There are, of course, many things that can be improved. Probably here, the events which are essentially coming, they're all coming in real time. So this thing is pretty dynamic, and sometimes clicking and selecting, for example, a signal might be a bit challenging. Okay, but of course, nothing is perfect, so it can be modified, the code, etc. Last component is this one, train isolation forest. And what can I say about it is that this is the actual file that allows our AI ML to be trained on the collected sample data. Again, in my case, the 20,000 events. But if you have retrained, if you want to retrain to 30K or 40 or more, you can easily do this with this file. Okay, this is the user interface. It's very simple, very basic. Um, um, yeah, you can see the flow in real time. You can also see if the model is running or if it's stopped. Um, the data that is getting evaluated, also the EPS essentially that flows through, and of course the actual noise reduction plus identified signals, uncertain classified events. And I have also added another category for indicators of compromise hits, that has to do with the threat intelligence component, which is on the next slide. So the threat intelligence component, let's take a look. The threat intelligence component and its logic, it's actually super simple. There is scheduled cron job, okay, which pulls indicators of compromise every 15 minutes from the integrated threat intelligence platforms and stores the IOC here in Redis. Redis is the local store where the IOCs basically live. There are different IOCs, but you can, of course, imagine IPs, domains, hashes, etc. This is where they're kept. Uh, the lookup time less than 1 millisecond per query, and yeah, every incoming event is checked against Redis before it gets its final score. By saying final score, I mean noise, signal, or uncertain. On match, the ArcSight schema field, device custom string 5, this one, is getting populated with some basic information, but basic metadata, saying something like IOC, for example, detected. Okay. Uh, a quick comparison, the traditional approach, um, yeah, what can we say about it? Events flow into ESM first, then the RU engine evaluates them. Threat intelligence matching happens at correlation time inside ESM. Rules must be manually written and maintained. This is something that we know very well. High event volume means ESM needs to process everything before any, IOC is actually detected. And detection is a bit, I would describe it and say, reactive. So a discovery happens after ingestion, after getting the data inside the ArcSight ESM manager. But that's normal. This is how it's been for many years, right? The AI powered approach, the machine learning approach, let's say, the events are intercepted at the transformation hub pipeline layer much before reaching the ArcSight ESM. IOC check is performed against the local Redis in sub-millisecond time. On match, the event is immediately tagged. Its device custom string with an IOC source, severity, category. The tagged event then flows and eventually reaches the ArcSight Enterprise Security Manager. So if you're an analyst, level 1, let's say, and you see inside your active channel that there is an event with an IOC flag, right? Basically, the moment you see it, you already know that probably you must start looking into it, okay? Additionally, on top of that, a noise reduction of approximately 20% in our environment based on the trained data. And yeah, it's significantly reducing the analyst workload, fatigue, EPS consumption as well. The list is long, is pretty long. Some key benefits and some of the current results. Of course, those results now it's in a test environment, so I couldn't I couldn't use, I don't know, 1000 TPS or 10,000 DPS. Plus, I mean, it's yet to be seen how it's going to behave and how many resources would be necessary, and whether if this whole idea can succeed or not. But in a low, let's say, EPS volume, it works pretty well. If it works pretty well in a low EPS, only resource limitation, I would say, might be an eventual issue, an eventual problem. But yeah, noise reduced, IOCs loaded currently in our environment, less than 1 millisecond lookup time. And yes, unlike traditional ESM based threat intelligence that detects IOCs after ingestion through the rule correlation, this system performs IOC matching much earlier. like we have already explained. Now I'm going to make a demonstration. The demonstration is going to be very quick. And there will be 4 phases. I'm going to start first with an AI model training. I'm going to train it on 25,000 events. We're going to see if the expected noise, whether if it will be reduced from the current 20-ish%. Okay, this would be something interesting. I'll be curious to see what will happen because right now I have no idea what will happen. But yeah, it, if you ask me, it should be reduced, the noise. Let's say this number here should grow to at least, I don't know, 30-40%, because retraining it on more data, the model is going to start learning, right? Uh, that most of these events are probably noise. Commands are ready to execute. We're not going to waste too much time there. I'm just going to be copying and pasting them. On an active channel, which is going to show some events with AI IOC detected. This is of course based on the threat intelligence. I'm going to use some well-known malicious IP addresses, and I'm going to push those IPs as part of the events that my smart connector is producing. So just to see whether if our threat intelligence component can retrieve those IOCs, and how quickly basically an analyst looking inside an active channel can uh, you know take a decision and see that, okay, there is something going on, probably I need to investigate even before a rule gets triggered, right? Push test alert events, evaluate first the AI ML behavior. Yeah, we're going to see this signal, uncertain, and noise. And then finally, we're going to explain also where the ArcSight database fits into this whole thing. But what I can just spoil and say almost immediately is that all 3 types of events, right, are going to get to the ArcSight database. Only ESM, right, is going to be, let's say, saved from not getting the noise. Okay, ESM is going to process both the signal and uncertain type of events, but ArcSight database is getting everything. Okay, so let's start the lab environment and let's take a look. Okay, so the first thing that I am going to do, I'm just going to go here under OPT, THAI processor, and then uh, here I have several folders: app, config, models, scripts, and then I have this one which is train. So I'm just going to go under train. And I'm going to show you as well this collect training file just for a second. Whoops. Collect training file. Okay. In it, if I scroll up a little bit, you're going to see that I have trained essentially my ML over 20,000 events. It's been ingesting live data from this topic. And then, yeah, the output file is this one. Okay. So I'm going to make a little change to that file from 20,000. I'm going to modify to 25,000. Oops, just one second. All right. So with this simple command, the target events, right, I am changing it to 25,000. And I can see also a proof that this has been done. Okay, now I'm going to run the collection of live data, and after that I'm going to train the model. Okay, so I'm going to start the collection of data. We have changed, I have changed the 20,000 to 25,000. So just 1 second, let me copy the command and just paste it. All right, enter. So you can see what it says, collecting 25,000 events from the TH AI inbound. Okay, waiting on seek to the end of topic, waiting for live events. I hope my smart connector is producing, yeah, some events. I can even check here. Okay, it says running 7 events per second approximately. Let's see if this would increase or not. But yes, slowly it will start gathering, it will start collecting those 25,000 events. I'm going to pause the video. You can see here it says collected 500 from the 25,000 events. And yeah, it's going to collect, by the way, in chunks of like 500. For example, the next chunk is going to be like 1,000, then 1,500 events. But yeah, like I said, I'm going to pause the video and I'm going to resume it after 10 minutes probably, or 15 minutes. We'll see how long it's going to take. All right, so you can see the outcome after collecting all 25,000 events. It took some time. It took like, I don't know, 20 minutes, something like that. This is of course due to the speed of my test alert connector. We can see collected 25,000 events, saved. It's showing where uh, this information was saved, and then severity distribution. This is based on the event severity provided on a connector level. Also some additional context, top vendors, Microsoft, Checkpoint, etc., etc. Now, finally, the time has come, the time to train our model. So I'm just going to copy paste the command. It looks like this: Python THAI processor, and then we're going under the train directory. So this is the train isolation forest. It's gonna take just a couple of seconds. So I'm just gonna press enter, and we can see what is happening. Okay, okay, it's over actually. Step 1, loading the training data. All the events were loaded, features against which they will be evaluated, training the isolation forest pipeline, okay, trees for stability, estimate, okay, training complete, evaluating the model, anomalous events, etc., etc. So yeah. Okay, and also there are some examples here for a typical signal, what is classified as a noise as well. Okay, so yeah, the only thing left is just to restart the TH processor, our model. Oops, sorry. I'm just going to type systemctl restart and then TH AI processor. Then I'm going to refresh here the UI, the user interface, and see what happens. Okay, so this is how it looks like after applying the model. The noise reduction is even greater. We managed to reach 63%. Of course, we're in a training environment, and yeah, we're not dealing with real data. So I'm not really able to measure, yeah, whether if these are accurate or not. But yeah, now I'm just going to test the threat intelligence, and let's see how the threat intelligence actually works. Just going to take and pick up something. Hmm. Okay. Um, I'm just going to look inside in the Redis for some indicators of compromise. I will just pick randomly one of these malicious IP addresses and then put it here under one event. Mm, source address, for example. Let's find the field. Okay. And then, yeah, I'm just going to basically send it. I'm going to forward it. So let's take a look. Okay, I just sent that event. We're gonna see almost instantaneous hit. Okay, IOC hit. And then if we open up uh, the ArcSight Enterprise Security Manager and one active channel, this is where the event appears. Uncertain, okay, this is how it has been um, um, categorized by the AI. But definitely here under device custom string, we can see IOC detected, and then a bit more context. We have the IP address, we have the threat intelligence, medium severity, and then brute force. We have the score, and yeah, almost instantaneous view. All you need is just one active channel. If we look from as well ArcSight database perspective, how it looks, you can simply just type IOC. Okay, I have created here a specific field set. I called it AI field set, and then just going to select last 15 minutes and then search. And we're going to see this exact event also inside the ArcSight database. Probably my session has expired, so yeah, I'm gonna have to log in. Uh, and just rerun the query one more time. Mm, not signal. I want to look for IOC, right? Just IOC search. And we should be able to capture that unique event right there. Yeah. Test alert, AI mode, and then the device custom string field again. Uncertain AI decision, and then we have the score also here. Uh, can we try with another indicator of compromise? For example, hash instead of IP. I'm gonna type here hash. I'm just gonna pick one random one of these, okay, and just go here. I'm going to remove the IP address, and I just need to search for the field called file hash. File hash here. Copy and then send. Okay. Here the TH AI processor will immediately identify this. And all we have to do is just to open ArcSight DSM console and wait for this second event. Here is the second event. You can see the file hash field this time has been populated, right? Again, the AI model has classified it as uncertain. But yeah, IOC detected. You have here the hash parsed, and then it says the threat intelligence is malware bazaar, right? And then it says malware sample. So immediate, uh, instantaneous view on what's important and what you need to investigate, what you need to analyze, even before it reaches ArcSight DSM. And yeah, I believe that this is uh, adding a lot of um, value to our products. Okay, so this was the short demonstration that I wanted to make, and thank you very much.